Hello everyone. In this video we will present to you our two-dimensional finite element solver application. We are Group Toblerone and group members are Kayra Dernek, Zübeyir Atlıoğlu and Musa Herdem. We have three different parts as pre-process, process and post-process. In the pre-process part, we generate our shape. We can use different inclusion shapes from this inclusion shape menu, circle, square or rhombus. We select our inclusion shape first and we enter the dimension parameters. A is width of our shape and B is the height of our shape. C and D represents node frequencies. E is inclusion shape parameter. It is radius for circle and edge length for square and rhombus. And then we can discretize our shape according to 5 different element types from this menu. D2TR3N has 3 nodes and 1 Gauss point per element. D2TR6N has 6 nodes and 3 Gauss points per element. D2QU4N has 4 nodes and 4 Gauss points per element. D2QU8N has 8 nodes and 4 Gauss points per element. And finally, D2QU9N has 9 nodes and 9 Gauss points per element. After we decide what we need for element type, we choose our inclusion as void or inclusion. Then generate button creates our shape. The shape we see is formed by elements, and we can also show element numbers and node numbers. Also, we can adjust their sizes from size button. Node sizes and element thicknesses change by adjusting this size button. These counters shows the number of nodes and number of elements. And we can reset our shape from the reset button if we need to start generating our shape from scratch. When we move on to process part, we can determine the characteristics of shape. There are Young's modulus and Poisson's ratio to adjust. If different characteristics are needed for inclusion, different Young's modulus and Poisson's ratio values can be entered. There are 3 different deformation types and these are extension, expansion and shear. After selecting one of these deformation types, in the next part we can determine deformation magnitude in meters. If 1D solution is needed, this box should be checked. When Run button is pressed, we can see results on the bottom left corner in the post-process part. We have different data for our simulation and we can see them from this drop-down menu. Stress and strain in XX, XY, YX and YY directions can be seen. We can also have deformation data in X direction and Y direction. We can change our figure's color from the color map and the edges of the elements can be turned on and off from this switch button. As another aspect, we can scale our results to magnify it. Now let's run different simulations for different element types for a circular void. And now we can run some simulations using inclusion and different deformation types. If we want to compare our results with 1D solutions, we need to check this one-dimensional box and run the simulation. In the post-process part, we can see stress value comparison and displacement comparison for 2D solution and 1D solution. And finally, let's create a beam and make a shear deformation.